Hello guys and welcome back. So I've run a high-res sim and it was caching live here, and this is the only frames left from the cache, and it erased everything else. And you can see there's a lot of cool details here and how much resolution we have. I can't tell now. Let's see. We'll import the fields temporarily and then I will explain what this is. Okay, we have 248, 153, we have 11 million voxels in this, and it took just less than 2 minutes to finish. So the reason it's only keeping this number of frames in blue cached is because under under cache, there is this limit to use only 5,000 gigabytes of memory. And once it hits that limit, it starts erasing the previous frames. And depends on how much memory you have and how much you like to cache the sim interactively. I generally set this to 30 because I have enough memory. And you can also allow caching to disk, but that will be slower as it will start writing the cache into disk, which is slower to read as well. So as if you're caching the sim for final. And I don't generally use that. If it runs out of memory, then that's it in this case. And let's see, let's go back. Let's sim a couple more frames. Just sim a couple frames. And what I'd like to do is I'm going to show how to import the data from DOPS now. Okay, cool. So the way it works now, we've done the preparation of the volume. One step, we imported the data in DOPS. We did the processing of the fields, we advected them and everything, and now we need to import them back in. And to do that, we need to use a DOP import fields node. I'm going to drag this guy here, and this basically allows us to read in fields from the DOP network. And we're going to point it to the smoke object 1, and here we can choose what type of sim we're importing, in this case smoke, and it will give us this preset, this default list of fields that we'd like to import. At the moment I don't care about the rest field, in which we don't have it, and I don't care about the velocity as well as temperature. I don't care about all of these, I just need density. Okay, now if we take a look, this is our field imported, and if I middle click, you can see it's a one volume, and it's called density. Okay, cool. And I'm gonna add some lights. So I'm gonna create a light. I'm gonna set it to distant. And I'm gonna give it a different color. I'm gonna copy this. Let me hide this guy. I'm gonna copy this and rotate it the other way and give it a different color and lower the intensity. Cool. So now we have a better preview. Now with this, we can also use a visualization node, volume visualize node, this guy. And this allows us to alter the OpenGL display of the view of the volume just in the viewport. So I can increase the density here. You can see it have a lot of cool details. We can increase the density for the shadows of separately from the density. And we can also view the temperature and various other things. And then once we have the data imported, we can simply output this into the anywhere we want. Let's call this sim/test.f4, and we can hit save to disk, and that will start caching the sim, and then we can read it back in. Cool. So let's continue now. What do we like to do to this? Let's take a look and see what we have. Now the thing that is missing is the actual collision with the tank, and the cleanest way to do collision with DOPS is using static object. So like we did here, we're going to create a static object, And what we need is we need the geometry to collide with. So I'm going to create a merge node and connect these two guys. We want the ground and the static object, and let's go back up and prepare some data. So this out surface here, I'm going to use that for the collision. This is my geometry collision. Okay, let's dive inside and browse for that. Cool. So let's hit play. And you can see we're getting a little bit of, there is some collision here, but we're going to verify what's happening in once we go outside. So let's go here and let's take a look at the data. And there is some nice collision happening right now, but it's not perfect. It's simply, it's working, but it's not ideal. And the reason for that is if we take a look at under this tab here, under the collision, and view the collision mesh, you can see DOPS tries to create, generates a volume to represent the geometry that we have. But these techniques always fail. Most of the time they fail to represent what the geometry really is and how it looks like. Now look at this, for example, it doesn't have, there is no blue, this is the collision geometry that DOPS created. And it's by far, it's very different to what the geometry is. And what we're going to do is we're going to use something called volume sample. And what this allows us to do is define our own volume for collision. And like we did the VDB from Polygon, we converted this mesh into a volume. I want to take this mesh and convert it back into a volume as if we have this as the input geometry. Forget this, and then we're going to start working from here. So I'm going to create a VDB from Polygon, and I want to convert this into a volume. So I'm going to set this to 0.025. Okay, let's lower it. I don't need it to be that high res. Cool. And this is our volume representation. Okay, I'm going to call this out VDB collision. And let's go back to DOPS. And under the way to specify what volume DOPS for DOPS to use, I'm going to use this proxy volume here, and let's browse for that out VDB collision. And now you'll see a much cleaner representation of the tank. Cool. So let's turn this off. Let's display the geometry back, and now we should see much cleaner collision with the tank. Much more accurate. You can see it here as well. Now the last thing I want to do is, right now we just have a force pushing the smoke onto this. You can see there is a lot of stuff getting stuck here. There is nothing, because of the force pushing them against the surface, they're not changing that much. And when we saw the reference, you can see that the smoke slides and follows the curvature of the mesh. And I'm going to create, let's see, toy. I'm going to create this geometry, and I'm going to try to explain something. So let's hide everything. And I'm going to create, let's see what this made of. Cool. I'm going to create a facet node to generate some normals, and let's view them. Cool. So this is the normals of the mesh. And I'm going to create a point VOP and compute a cross product of that normal with an up vector and see what that gives us. Let's take a look and look at the result that we get. We get something that follows the curvature of the mesh instead of just, let me change this to flat. Instead of just pointing upward, you can see these guys are following the curvature of the mesh. And if we create something, if we create a force that we can inject into the smoke to also help push it along the surface flow, we can get some really interesting details out of this. And I don't I don't just like this direction. I want to create something else. So what I'm going to do is I'm going to take this result of the cross product. I'm going to create another cross product. And I'm going to compute the cross product of this new result using with the original n, with the original normal. And that's going to give us a different direction. You can see now we have a different flow in this direction. And I like to mix both of them. I like to have 50% of this and 50% of the other. And this way we have very interesting flow that moves in both directions. We can also add noise. Let's actually add the noise here. So we can create some noise. It's a scalar, and use that to change the surface flow. And let me fit range this because it goes from -1 to 1. I'm going to fit it between -1 and 1. And you can see now, let's increase the frequency. You can see now we're getting more breakups in this. So let's copy this guy and let's reapply the same thing here. And this is our original surface. We don't have a normals yet. We don't have n. So I'm going to create a facet node. And let's compute the normals. Cool. And I'm going to do the cross product after because I want the computation to happen at the point level. So I'm going to take these points which inherited the normals. I'm going to paste that same node here. And let's take a look at the normals now. Cool. So you can see now we're getting an interesting vector. This is the original one. It's pointing outward. And then if we take a look at this, you can see now it's following the surface in a very interesting way. And I want to use this as a force, as an extra force for the emission. I also want to add more points because I'm not getting a lot of details, so I'm going to set this to 1 million. And let's use that. Cool. And now under velocity, it's sampling the points already. Sorry, it's not the velocity. We don't have a velocity yet, so we need to connect. Instead of n, we need to inject this into the velocity, and now we should see the velocity being created, and that's the display of it. Let's take a look at different axes. This is one direction, and this is from the top. You can see how it's following the surface. We can also slide the streamer to show us different values at different areas. Now I want to inject that as well into the sim. So let's go back and let me lower this a little bit. So 1.5. And let's increase the velocity here. Previously it was set to 1, but because there was nothing coming, we didn't see any end result. Now let's see what's going to happen. And you can see it here a little bit. Oh, we'll take a look once we go outside. Let me hide the display of this geometry, static geometry, because I think it's abstracting with the viewing. Cool. So the other thing that's happening is because we're disabling this node after frame 13, there's no velocity being emitted anymore. And what I'd like to do is I'm going to use I'm going to keyframe the density and leave this on forever. And I'm going to set the density to be 0 at frame 1, and then it goes up quickly. At frame 3, it goes up to 3, and then dies off at frame 8 to 0. Okay, and let's take a look. Cool. And you can see now we're getting all the surface is being pushed from the geometry. Okay, I think we're heading in the right direction. Now the smoke is not dissipating at all, and I want to dissipate it a little bit. Well, we want to dissipate it a lot, so I'm gonna add a gas dissipate, and the field we're interested in dissipating is density. And I want the evaporation rate to be high on this. I'm going to set it to 0.8. And let's hit play. Cool. So we're getting a lot of interesting details now in terms of velocity. The next thing that we're going to do is we're going to add a little bit of noise to the overall scene. You can see the dissipation working. We're going to add a little bit of turbulence and create a couple of them to layer different swirls size on top of this. And let's take a look at this. Nice. And let's do a preview so we can see it. I'm gonna template this guy, or actually let's template the original geometry, and let's do a preview. Cool. So I think everything is working at this point. We just need to add a little bit of turbulence to break this up even more, and maybe keep the wind pushing for a couple more frames so it doesn't stop at this point. You can see we don't have any smoke left on the object because we have a very strong velocity that helps get rid of it close to the surface. So we're getting a lot more details being pushed here, and I think the impact as well is working nicely now. Cool. Okay, let's I'm gonna sim a high-res version because I'd like to show you guys this in a high resolution, and then we're going to continue add more details onto this. Thank you for watching, and see you in a bit.